Good morning, everyone. Hope all is well. All right, I think everybody's in. Okay, so last class we covered 1-4, and today we'll get into 1-5. All right, so let's go to see if we can knock out 1-5 and I send you guys off into the weekend. All right, so we have 1.5 quadratic equations. So our general form of a quadratic equation is ax squared plus bx plus c equal to 0. So in problems that we dealt with up to this point, we were getting one solution. We had linear equations. So now we're looking to get two solutions. We have a second degree polynomial. In other words, the highest exponent on your variable is 2. So we should be looking to have two solutions. So for the most part, that highest exponent on your variable will let you know how many solutions you'll be able to get. Sometimes you have repeated solutions, but still, even if it's repeated, then those will be two solutions. So there are 4 methods in this section that we will talk about. We have the zero factor property, square root property, completing the square, and quadratic formula. All right. So let's look at the first method, zero factor property. So 2 keywords there, zero and factor. So notice how it says if a times b is equal to 0, then a is equal to b, a is equal to 0, b is equal to 0, or both. So we're going to use factoring. I'm going to still have my eraser on. We're going to use factoring, and one side has to be equal to 0 before you go about solving. So looking at this, how we're going to apply this. If I have once I have my expression factored completely, here we have x plus 5 times x plus 2. Then we can set each part equal to 0 and then go ahead and solve. So once I have it factored completely, x plus 5 times x plus 2, it has been factored completely. Now I can set each piece equal to 0 and solve. So that's why I have x plus 5 equal to 0 here. Subtract 5 from both sides. My solution is x equal to -5, and then I have x plus 2 set equal to 0 here. Add 2 to both sides. Subtract 2 from both sides, excuse me. X is equal to -2, so I have my 2 solutions. But the key is that we have to factor our expression as much as possible. All right.
Mr. Tucker.
Mm-hmm.
When it comes to the example, why couldn't you in the example, why not just FOIL the X thing out, or you just need it like that?
So if you FOIL it out, then you have to ask yourself, then where are you going? You know what I mean? So mathematically, you always got to make sure that whatever you're doing, you have a thought process as to where you're going when you're doing it. So if you FOIL it back out, you're going to expand it out. And then what's the next move? You see what I mean? So here you break it down to this so that my next move is to x plus 5 equals 0, x plus 2 is equal to 0. And so that's why you're breaking it up. See, really, go ahead.
So x plus 5 equal A, and then x plus 2 equal B?
Yep, you can look at it, yep, from that, from the setup, yep. All right, so going back to what he was saying, if I were to FOIL that out, then that puts me back into this position. And once again, you have to ask yourself, if I'm in this position, then where do I go from there? So our goal is to take our expression and factor out as much as possible so that I can go into setting each part equal to 0. So here we have 4x squared minus 2x equal to 0. If I were to factor this, I can factor 2x out from each term. So that's 2x times 2x minus 1 equal to 0. Once again, if we're talking about factoring and you have holes in your factoring, make sure you email me so we can try to make sure you're straight. Either I need to send you a video on factoring, or we need to meet in Zoom, a separate Zoom session, talk more in detail about factoring. But this is only a segment of a section, so they're not spending that much time on factoring skills. So just throwing that out there. So once you factored out the 2x and factor that expression as much as possible, then you can set each piece equal to 0. Originally we have this going on. 2x equal to 0, 2x minus 1 equal to 0. And then we can go ahead and go about solving both. In the first one, we divide 2 to both sides, and that'll be x equal to 0. And then the next one, over here, you add 1 to both sides, then divide by 2. X is equal to 1/2. All right, problems with those two solutions.
I have a question. Do we have class on Labor Day or no?
No, man, unless you're trying to make it happy, I'll make anybody happy. Y'all trying to roll with it. No, no, we're not supposed to. So no, we should be good to go. Thank you for bringing that up. Yeah. I'll probably shoot an email out just to remind folks, All right, so the next one, 2x squared plus 7x equal to 4. You want to set one side equal to 0. Remember, it's called the zero factor property. So subtract 4 from both sides. And we have 2x squared plus 7x minus 4 equal to 0. All right, so from here, there are multiple ways of factoring a trinomial, whichever one you're comfortable with, the most definitely you're fine. If you're going by trial and error, you know that this minus sign right here lets you know you have different signs in your parentheses. We have 2x as our first term. 2x times x gives me 2x. So that's why I have those two pieces. And then we have 1 and 4 in the back. Remember, these are our options when we talk about multiplying two numbers to get 4. 1 times 4, 2 times 2. So if you tried 2 times 2, it would not work. But 1 and 4 does work in that order. Also remember that whenever factoring, if you were to multiply this back out, you should get what you originally had. If that does not occur, then that's not the correct factorization. So always remember that you can always check your factorization by multiplying it back out. And once again, it will give you what you originally had if you have the correct factorization. From there, you set both parts equal to 0. Yeah. If you need anything, shoot me an email, because I promise you I'm going to forget, from here once we close out class. So shoot me that email on what you need from me. And then, yeah, it talks about all the basics and all that stuff like that. Yep. You can, if you know the AC method, factoring by the AC method, and you break up to 7, you can use factoring by grouping. But remember, you only can use factoring by grouping if you have 4 more terms. So once again, you will have to break this 7 up. So that's leaning on another method. That's not I did trial and error, but that's the AC method. All right. Questions on our 2 solutions? So let's do at least one more. Once again, it's leaning on your ability to factor. And then once again, once you factor completely, set each part equal to 0. So here we have x squared minus 13x plus 36 equal to 0. Here is a little more simpler than the last one. Now your back sign, if it's positive, means both of your signs should be the same. So notice both of them are negative. And all we have is 36 to look at. That x squared is just x times x. So you look at your factors of 36 that will add together to give you 13. And the only option there is 9 and 4. And so x minus 4, x minus 9 would be that. All right. And so go ahead and set that equal to 0 and solve. So yep. Now a lot of people asking for that video. I'm still going to need because this is not a normal part of my thought process of, shoot me an email to remind me and I'll send it to everybody. It's not a problem, but I'm pretty sure I'm going to need a reminder through email to send that video out. So yep. I'll send it to everybody. You say you're working on that email. Yep. Appreciate it. And then, yep, I'll send that out. All right. Any questions on what we did here? Oh, hit the wrong button. Hold up. Let me put it back on. What I do? All right, there we go. Anybody still copying this before we go to the next method? Very good.
Is this just a factoring review?
No,
or
it
is this
was
homework.
It was we're in 1.5, and one of the methods that we're covering is solving by the zero factor property. So you're using factoring to solve quadratic equations.
Okay.
All right. So remember we said we have 4 methods here to solve your quadratic equations. Our second one is the square root property. So it says if u squared is equal to d, and you want to solve for u, remember we need to undo what's being done to the variable that we're dealing with. So we take the square root of both sides. So whenever you have to take the square root of both sides, plus or minus has to be involved. So here's a light example of that. We have x squared equal to 25. I want to solve for x, so I need to undo the squaring of x. So to do that, I would take the square root. Taking the square root of both sides, square and square root cancels on the left. Leave me with just x. But what the square root property says is that if I take the square root of both sides, then plus or minus has to be on the other side where the square root and square didn't cancel. All right. So that gives me plus or minus square root of 25, which is plus or minus 5. So the reason why that happens is, remember, whenever you're solving for x, you always want all of the values that will make this a true statement. So now when you're talking about what are all of the numbers that when I square it will give me 25? Well, 5 times 5 is 25, but also -5 times -5 is 25. So that's why you have to give an account for the positive and the negative result whenever you take the square root of both sides. And plus or minus symbol gives us that. And also don't forget we need two solutions because we're dealing with quadratic, and also plus or minus provides that as well.
So you're saying because it's plus or minus, that equals the two answers?
Yes.
Okay.
Yeah,
So would you,
positive 5 and -5. Somebody say something?
yeah, so we use the square root property whenever our finished x product is the second power.
Well, you use the square root property when you want to take the square root of both sides. And the reason why we take the square root of both sides is because I have a square on the x. And you want to solve for x.
Would this follow for a cube root?
No, because when I cube 2, that's 8. But when I cube -2, that's -8. You get a different answer. See, when you square 5, you get 25, but when you square -5, you also get 25. So this same thing will hold true for even powers or even roots. So now if you get a 4th power, then you have to incorporate that. It's just that we're not dealing with that type of stuff right now. So we're not going that high, but it's all about even powers. Now, you know what I'm saying? We can go there now. You want to go to the 100th power, we can.
Oh,
Let's save that for later.
if he does that, we're all blaming you.
All right, can we scroll up, put this in action? Everybody good? All right, let me erase this. So we have 9x squared plus 25 equal to 0. Once again, your goal is to get x by itself, so you're trying to solve for x. So first thing we do to isolate the x is subtract 25 from both sides. That will give you 9x squared equal to -25. And we can divide by 9. And that result will give us x squared equal to -25 over 9. Now from there, your goal is to get this square off of x. Take the square root of both sides. They cancel on the left. And then once again, just reemphasizing what has to happen. If you take the square root of both sides, plus or minus has to be involved. So now we have plus or minus square root of -25 over 9. Then we can take the square root of -25, take the square root of 9, and that's 5i over 3. So don't forget, whenever you're taking the square root of that negative, it is imaginary. All right. Any questions before we do another one? All right, Ms. Miller?
Oh, I'm just trying to catch up here for a second. Sorry,
Okay.
I
Did I
flew
go
in
too
on
long?
Monday morning from a last minute trip, so I'm just trying to catch up.
Not a problem. Did I go up too high or?
No,
Okay.
I remember this part
Okay, cool.
of the class, so.
All right, so next one, we have x minus 2 squared equal to 0, equal to 6. So notice the whole quantity of x minus 2 is being squared. Currently, I do not have access to x. I need to remove the square off of x. So just like before, if I'm trying to remove a square, I undo it by doing the square root. Take the square root of both sides. The square and square root cancels on the left. And then on the right, I have the square root of 6. Now, the square root of 6 cannot be evenly square rooted, so you can leave the 6 under that radical. But don't forget the plus or minus part. You know, plus or minus goes in front of that square root of 6. And then from there, to finish solving for x, we can add 2 to both sides. And normally that goes in front of the plus or minus. So you have 2 plus or minus square root of 6. Now, I forgot whether my math lab has made it available for you to be able to use a plus or minus sign. If not, then you'll just have to write out both, you know, 2 plus square root of 6 and 2 minus square root of 6. So just, you know, note that if you don't see this as an option, then you have to write them out. All right, any questions? All right. Next one, very similar in setup, but the outcome is a little different. So I wanted to make sure I went through this. X plus 4 squared equal to 81. So once again, we want to square take the square root of both sides because we want access to that x. So we take the square root of both sides. Square and square root cancels. On the left, leave me with x plus 4. On the right, once again, plus or minus square root of 81. That square root of 81 turns into 9. Now we can subtract 4 from both sides. Now the difference between this one and the last one is that this one, you can add 4 and 9 together, and they are expecting you to do so. So you are expected to finish off the problem going back here, because we couldn't take the square root of 6 evenly. We left the 6 under that radical. Once again, here, square root of 81 is 9. So since I can add these together and subtract them from each other, you are expected to do so. So -4 plus 9 is 5. And then -4 minus 9 is -13. And then here, I was just emphasizing that if you have imaginary, same thing, you just leave it the way it is, because you cannot add real and imaginary together. So you can leave it like this. But when you can, you are expected to do so. Any questions before I go to the next method? I think Mr. Williams is gonna like this next method.
Oh, I'm not gonna like that one. So show me how you got to the 6i after you
Oh,
break
this
down
was
to -4.
that was a random example. I was just saying that if you had, you know how here we left it as plus and minus, here we didn't because we could add them together and subtract from each other. I was saying this scenario, you would leave it as plus or minus as well in your final answer, because you can't add real and imaginaries.
All right.
Yep, random example. Yeah. I should say something like that, random. All right. So completing the square. Got some steps here. So everybody done with that last example? Scrolling up. Okay. So third step, not third step, but third method to solving your quadratic, completing the square. So we want to solve ax
That
squared.
is so many steps.
Why you said why?
That is so many
Oh.
steps. What is that?
Well, once we start doing it, you got to remember I put the process into words. Once we start doing it and you actually get in the flow, it's not that bad. You just got to stick to the process. You know what I mean? But I had to put it in words so you guys could, be able to do this on your own. So yeah. So we're gonna notice we have ax squared plus bx plus c equal to 0. If a is not equal to 1, then we're going to divide both sides by a. So notice when we're referencing a, we're talking about what's attached to x squared. When we're referencing b, the number that's in front of x. And then c is our constant. That's the number that's not attached to x at all. So whenever you see a, b, or c, that's what we're referencing. So if a is not 1, then we're going to divide both sides by a. In other words, divide each term by a. Then we're going to isolate c to one side of the equation. Out of confusion. So we're going to isolate c to one side of the equation. So we're going to push the c to the other side. Then we're going to take half of b and square it and add the result to both sides of the equation. Give you a chance to write before I scroll up. Step 4, we're going to factor the perfect square trinomial and simplify the other side. Are you done with the first step? Then solve the square root using the square root property, which is what we just did. And then step 6 is always, your final step is always to check, whether you decide to do so or not. Of course, it's up to you. All right, let's try it out. So first one, x squared minus 6x plus 4 equal to 0. So notice that 1, a is equal to 1, so there's nothing to do. So I'm gonna say something in the chat. I will try to post the videos today. I try to let Monday and Wednesday's lecture so I can post them both at the same time. So after today or after today's lecture, I'll try to post it this evening. That's my goal. All right, so notice a is equal to 1. So there's nothing to do here. Remember, the first step was based upon a not being equal to 1. All right, so we don't have anything to do in this first step. Yep, not a problem. So second step, we're going to isolate the constant. Our constant is 4, so we're going to subtract 4 from both sides. And now we have x squared minus 6x equal to negative 4. All right. Third step, our b is negative 6. We're going to take half of b and then square it. So remember, it's called completing the square. We're trying to create this perfect square, your perfect square trinomial. And so this is a part of the process. So taking half of b is -3. Squaring -3 is 9. So you add that 9 to both sides of the equation. You take half of b, which is -3, then square that, and then add that to both sides of the equation. All right. After that, step 4, we are going to factor this trinomial over here. Now, if you don't, let's say if you don't know how to factor, like in the next one, we'll have a fraction. If your factoring skills, it's not as great as you would like for them to be, or you just don't see how to factor this, whatever half your b term is what goes here. That's always going to be the case. So notice half of -6 was -3, so we have x minus 3. So that will always be the case. You know, we have x minus 3 squared, and then it's equal to 5 because -4 plus 9 is 5. All right. Questions on what I just said there. When you go to factor, when you go from step 3 to step 4, trying to factor that trinomial, whatever half your b term is what goes in parentheses with your variable. Half of -6 was -3. That's why we have x minus 3 squared. And then on the right, -4 plus 9 is 5. I think I want. All right. Now, step 5, we'll solve it. Solve the equation the way we just finished dealing with the square root property. So we have x minus 3 squared equal to 5. So now we take the square root of both sides. Square and square root cancels on the left. And don't forget your plus or minus. That's now on the right with that square root of 5. So we have x minus 3 plus or minus square root of 5.
I apologize. Can you explain to me? I understand why +9 is on the one side. What I don't understand is why +9 is on the other side of the equation.
If
Is it
whatever
because
you
we added it to one side, we have to add it to the other?
exactly. Yep.
And we
Got it.
missed that step, and all of this is messed up.
Oh yeah. Oh, for sure. I agree with that. So now the -4 came from the original problem. So remember right here when we subtracted 4 from both sides. Somebody said, what about the -4? Yep. But like she said, whatever you do to one side of your equation, you have to do to the other side in order to keep your equivalency. So if you add 9 to one side, have to add 9 to the other. All right, let me see. Okay. Yep. So now you go ahead and add 3 to both sides, and our result, our final answer is 3 plus or minus square root of 5. All right. Is that so I wrote I? Was that intentional in the chat?
So what is the name of the fourth step? Are we just
Well, you just factor the left side and you simplify the right side. You know, we factor that.
okay.
Yeah, so you just factor this trinomial and then simplify the other side. All
So
right.
3 is to factor and 4 is to factor?
No, 3 was take half of your b term and square and add 9 to both sides. That's what, you know, add that result to both sides. And 4 was us factoring the result from 3.
Factor.
Are you
5.
always going to be factoring the left side and simplifying the right, or can it be written the other way?
You can do it the other way. It's just that.
Of course you can.
Because cause basically, if you have 5x equal to 7, 7 equal to 5x, that's still the same statement. So if that's what you're referencing, yeah, you could have had -4 plus 9 on the left, and then x squared minus 6x plus 9 on the right. Yeah, you could have had that. It's just that, that means you would have been factoring what's on the right and simplifying what's on the left, because your trinomial is over here now. But yeah.
Okay.
All right, let's try it again, right? So next one, 9x squared minus 6x minus 4 equal to 0. One side is already equal to 0, so we're good to go there. We can just isolate, follow the steps that we have. And the first step is that a is equal to 9. Remember last time a was equal to 1, so there was nothing to do. This time a is equal to 9. It's not equal to 1, so we're going to divide each term by 9. And so that's what I did right here. 9's cancel in the first term. In the second term, we have 6 over 9, which is 2/3. 4 over 9 can't reduce any. And then 0 over 9 is 0. So that's why we have x squared minus 2/3 x minus 4/9 equals 0.
Why are we dividing by nothing?
First step is if a is not equal to 1, then you divide by whatever a is. All right. So now that second step, we want to isolate our constant. So in other words, that 4/9, the number that's not attached to a variable at all. We want to move that to the other side of our equation. So we add 4/9 to both sides.
At this point, can I just say that I'm not looking forward to the rest of this problem?
It's understandable.
Last time was like manageable. This time
Mhm.
there's too many fractions.
It might not be that bad, right? Might not be that bad.
It's a possibility.
So we have x squared minus 2/3 x equal to 4/9. Can I scroll up if I don't with first step? All right. So let me erase some stuff and walk through it in a second. Just trying to get to a good place. All right. So now don't forget the process is still the same, even if you have fractions. So now third step is to take half of your b term and then square it. So taking half of -1, -2/3. So you can go ahead and cancel the 2 that's in the column with the top and bottom. And that'll leave you with just 1/3. Or -1/3, because that was a -2/3. And now -1/3 squared is -1 squared, which is 1, and 3 squared, which is 9. So we have 1/9. Then you take that 1/9, add it to both sides. X squared minus 2/3 x plus 1/9 equal 4/9 plus 1/9. Problems with what I've done.
Not necessarily, we'll need more practice.
And some questions may not even come up until you do exactly that. I always try to throw that out there as well. I can understand if you don't have any questions right now, but once you get into my math lab, you may have some. And I want to go back here too, because somebody mentioned in another class. If you set up a time to meet with me through Zoom, or not through Zoom, but individually, or even if you have questions, you know, during class or whatever, always make sure you bring the question that you actually had so that we can actually attack the issue that you had with that problem, and go from there. So because it's kind of hard to pinpoint where your issues were if you don't have the exact problem that you were dealing with. So make sure you bring those to the table so we can, you know, streamline what we're going to do and go ahead and make proper use of our time. Bracy, hand raised.
Yeah. So I want to ask, was it a happy little accident that 9 happened to be A, which allowed 1/9 to add up with 4/9?
A lot of this stuff is by design. So I wouldn't say accident because I didn't do the, you know, the groundwork, whatever Egyptian or Aristotle, who did it, whoever did it, they did some groundwork. And that's why I like stuff like this, you know, wherein you don't even have to really factor. -1/3 is that piece that go in there, you know, that's from taking half. Like they did some groundwork where a lot of this stuff do match up according to the processes and foundations that they established. So yeah. Yep. All right. So going into step 4, nice segue to step 4. Once again, if you're not comfortable with factoring, you don't have to be, because whatever half of your B term was is what goes here with your X. So half of -2/3 is -1/3. That's why we have X minus 1/3 squared. And then like Mr. Bracy was alluding to, 4/9 plus 1/9 will give you 5/9. All right. So before we
How exactly did you add 2x/3 plus 1/9?
did not. Now, when I fold this out, all that is going to happen. Remember, that's what this represents. So then you have to FOIL. And then you have your middle terms that combine to give you the 2/3 in the middle. 1/3 times 1/3 is give you this 1/9 right here. So, yep. So don't forget your factoring has to be expanded and then multiplied out to give you, you know, that. All right. So now once you're in this position, we can go ahead and take the square root of both sides to get the square off of the parentheses. That allow the square to cancel. That gives me X minus 1/3 equal to plus or minus square root of 5/9. So in the blue circle, I just went ahead and broke it up, square root of 5 over square root 9. That's what that represents. So we can simplify it a little bit further, but not all the way, because you cannot take the square root of 5 evenly. So you leave the 5 under the radical, but you can take the square root of 9, which is 3. And so that'll be square root of 5/3. Also, I don't think I emphasized it, but just to reemphasize, plus or minus, we took the square root of both sides. So plus or minus has to be involved as a part of your equation now. Then from there, add 1/3 to both sides. And your answer will be 1/3 plus or minus square root of 5/3. Or if you wanted to write it this way, 1 plus or minus square root of 5/3, you could. So if your denominators are the same, you can bring them together and make it one solid fraction. You don't have to, but just throwing it out there. Sorry, sir. If I could, I would give everybody A's and just going on, man. But see, thing about that is people don't know how to be quiet. It's always somebody who will say, yeah, man, you should take Mr. Tucker, man. He'll just give you A. Then next thing you know, I'll have a job.
I'll be quiet. I got money for people to be quiet. I got hush money for all of y'all. We can just do that.
Williams. If you're going to mention anything, don't mention it while it's recording or send it through a school email to a school email. Obviously, ask to arrange a private Zoom tutoring lesson, and then when it's not recording, make any propositions there.
Sounds like somebody has a little bit of experience. Oh man, but it's
That's
always one.
sketchy and you know it.
Oh man. All right, so we have one more method. So as always, try the stuff out. If
No, we don't. That's it. We're all done for the day.
Right to every one of your classes. I'm so sorry. So we have one more method. This method is lighter. To me, it's lighter. We don't have steps. I promise you there aren't any steps like that. But it's just a quadratic formula. We're just gonna plug in some numbers and then calculate. And then yeah, that's it. That'll be it for today. I won't go into anything new. I'll just leave it at that. And we'll check on out. So yeah, quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Notice once again, our formula, or not a formula, quadratic equation is set equal to 0. So before you pick out what a, b, and c are, you want to make sure one side is set equal to 0 first. And then go ahead and do that. And don't forget also, a is what's in front of x squared, b is what's in front of x, and c is the number that's not associated with the variable at all. All right, let me erase this. So first one, 8x squared plus 2x equal to 1. So first move is to set one side equal to 0. And so we'll subtract 1 from both sides. That's 8x squared plus 2x minus 1 equal to 0. Once you've established that one side is equal to 0, you can also establish exactly what a, b, c will be. A is 8, b is 2, c is negative 1. All right, once you've established that, you can go ahead and plug them into the equation. To the formula, plug them into the formula. Make sure you don't lose this negative out here. Oh, I had my eraser up. Make sure you don't lose this negative out here. A lot of times people will lose that negative. That is a part of your formula is negative b. So that'd be negative 2 plus or minus square root of 2 squared minus 4 times 8 times negative 1 over 2 times 8. So from there, you can go ahead and simplify what's under the radical. 2 squared is 4. Negative 4 times 8 times negative 1 would be positive 32. 2 times 8 on the bottom would be 16. Under the radical still, 4 plus 32 is 36. Square root of 36 is 6. Now, once again, we have a scenario where the negative 2 and the 6 are expected to be added to each other because you can. So we would go ahead and take it to the next step. Anybody? I'm okay with scrolling up. Let me know if I'm not. So that'll be negative 2 plus 6 over 16, negative 2 minus 6 over 16. And that gives us 4 over 16, which reduces to 1/4. Negative 8 over 16, which reduces to negative 1 over 2. Yeah, I told you it wasn't that bad. I mean, especially after coming out of completing square, right? It's not as bad as what we just what we just went through. So yeah. All right. Any questions before we do another one? All right.
No, just need a minute to copy down that
Okay.
last bit that's in purple.
Okay. Take your time. All right. Quick question. Is that Kessia or is that Keisha? Is that, you know, people do
It's
stuff different.
it's Keisha.
It is Keisha. Okay, I thought it was
Yeah.
Keisha, but I was like, because people do stuff different in there. Okay,
Yeah,
okay.
I've heard it all. Keisha, Cassia,
Yeah.
KC. It's
See,
Keisha.
I was like, I think that's Keisha, but I'm not sure. Okay, that's neat. I haven't seen it spelled that way before. Okay, cool.
Thanks for asking.
Not a problem. All right, so let's look at one more. Make sure we're okay. So we have 3x squared minus 2x plus 4 equal to 0. It's already equal to 0, so we're good to go on that front. Now a is equal to 3, b is equal to -2, c is equal to 4. Once again, make sure you don't lose negatives as we go throughout the process. B is equal to -2. All right. So plugging it into the formula, that is going to be -2. All right, there was a negative in the formula, and we had -2, that was b. Then that's plus or minus -2 squared minus 4 times 3 times 4 over 2 times 3. We done with the purple, right? Okay, negative to negative turns positive, so that's a +2 now. Plus or minus -2 squared, which is 4. Then we have -4 times 3 times 4, which is -48 over 2 times 3, which is 6. Under the radical still, that's -44. And then the green, you see that I went ahead and broke that down. -44, you break it up into -4 times 11. That -4, take the square root of -4, that give you 2i, and then leave the 11 under the radical. Scroll up, very good. Up. So now we have 2 plus or minus 2i square root of 11 over 6. We can reduce this, and also we recognize since it's real and imaginary parts, we need to break it up. Take that 6 into both pieces. That'll be 2 over 6 plus or minus 2i squared root of 11 over 6. And that reduces to 1/3 plus or minus I square root of 11 over 3. All right. Questions, questions, questions. All right. So this is a good place to stop. Like I said, 1.6 and that's it for 1.5. That's all the methods in 1.5. So next class we'll get into 1.6, other types of equations. Then you guys can't wait. Let's see. So what percentage of our grade, our tests were? Tests are, I think for this class, 55. Oh, yeah, 55. Yes, because your homework is 30%.
Oh, half. Got it. Thanks.
Yeah, but the thing about it is your homework, which is unlimited amount of tries, can bring your grade up Homework alone? Nah, it'd be tough to pass off homework alone. But your homework can really, if you do your homework and do all of your homework, it will bring your grade up. Yeah, and put you in a decent place. Really, I'll be honest with you. I mean, unless you're scoring like 20s on tests, then we might have to have a discussion. But if you do all your homework, I don't know what the lowest test grade you can have, but you can kind of score kind of low and still get that C.
How many points do you get for putting your name on the paper?
Well, I can shoot you 5 if you need it. I mean, I can shoot you a cool 10 if you want.
Oh my God.
You could probably
Now
shoot me
you-
100 and I'd still hurt.
Now you said that just the first test is open note, so the rest of the tests we're using a lockdown browser?
No. I just said that's the only one that's posted right now. So I know for a fact your first test is going to be is not proctored. That means you get to do it, on your own. And your final exam will be proctored. So I know for a fact those 2 bookends will be the case. Now I try to get at least one more proctored in there, and then the other one probably be unproctored. So just trying to gauge how well class is receiving certain topics and stuff like that, and then we'll talk about it. Whatever we do, you will have enough time in advance to prepare. But I know I want to at least get one proctored test before the final exam. And you never know, stuff happens. COVID hit. I mean, you just never know. Inclement weather, and if all
Well, here's to hoping.
if it don't work out that way, it don't work out that way.
Hoping for another pandemic. That's
For real, because I swear I'd
That's
rather
so
be stuck in the
aggressive.
house.
But I know regardless, the final exam has to be proctored. And then, to be honest, I mean, it's me over here and y'all over there. It's not like proctored me come into the room, so we're never going to meet face to face at all this semester. So it'll still be through Zoom. It's just that you have to enable your camera, and we just go from there. I guess the pressure of me looking at you might be an issue, but yeah, it'll still be the same flow.
Before we get
Oh,
off, I
no,
did have a couple of
proctoring it.
questions on last lesson.
Okay.
Homework, if you could have time to go over those 2 problems.
All right. So did anybody else, somebody else was saying something?
Nothing.
Oh, okay. All right. So if you want to stay on, you can. If not, then you are free to go. That's it for the lecture today. I'm going to address her questions and then we'll roll out. So if you're good and I'm good, have a great weekend, be safe, and I will see you next class, which would be Wednesday. Right? Memorial Day.
Yes.
Labor Day.
No, Tuesday. Wait.
Tuesday. Hold on. What do we do? No. Yeah,
We're Wednesday.
Oh, yeah,
We're gonna say
Wednesday.
Monday.
Yeah,
It's
Wednesday.
not Tuesday.
I was like, wait a minute.
All right, Ms. Dawn, what you got?
Okay, so 1.4 question
You the same,
12.
take care.
12, I only got it right because I guessed.
Okay. What did it look like?
It's clicking, it's coming up. All right, so it is 3 square root negative 18 plus 2 square root negative 50.
Oh.
And I kept coming up with, I don't even know now. I think it says like 7 squared equals 49.
Okay, so let's see.
But I don't
So
know.
you break up the negative 18 into negative 9 times 2. That'll give you 3i square root of 2. Here, this negative 50. I don't need to write that part.
I was doing it all wrong. I don't even know what the hell I was doing, honestly.
All right, so that's how we would break up both of those square roots. Make sure you're okay with that. So that's what we're looking at now, these parentheses. And then 3 times 3 is 9. And then 2 times 5 is 10. And that'll be 19 square root of 2. All right. How does that look?
Yep, I will review it and try and figure that out.
Okay.
The
Now
black
that
Looks
part stuff is part of it too.
hieroglyphics.
I'm just trying to
Like
copy,
hieroglyphics.
serious copying, and I honestly during class I have no idea what you're talking about. I just
Okay.
copy the work
Me
and then I try to figure it out
either.
afterwards.
Kitty
Okay.
wants to
Same.
help.
Yeah, I feel the exact same. It's like I'm jotting all this stuff down and I look up and then there's like all these different things that weren't on the screen like 10 seconds ago.
Yep,
And I'm
and
like,
I just have no
oh,
idea.
yeah.
My brain
And
can't
I've
think
found
and hear at
myself,
the same time.
not with this, I can't. And
Mm-mm.
for some reason, I found myself like I have gone back through these lectures. Well, the only 2 that you sent out so far, but I've actually written some of the problems down wrong because I was just writing so fast and furious.
Oh, wow.
And it's thrown me for a loop because I was trying to do it in an improper math form.
Mm.
So I really think for one, I need that factoring video without a doubt. Because I
Okay.
think that
Sure.
is kicking my butt on some of this stuff because it's like assumed things in the notes and I'm not picking up on that. So
Yeah.
that factored in with some of the like just fast and furious writing and me having to go clean my notes up because I've now noticed that that was part of the problem. A plus was supposed to be a minus or vice versa. So it was like I was following what I thought was right
Yeah.
and
Yeah.
doing what was on the paper, but never coming up with the right result.
Right.
And
Yeah.
then
Oh,
like
I
would
did that
go
on one of my
watch-
homework problems. I copied it down wrong. I copied an 8 instead of a 6, and I got the whole answer wrong. I was so pissed.
Oh, yeah. That'll do it
Yeah.
for sure.
And then, so the other one was question 14.
Okay.
And so that's a fraction. It's negative
Can you do
8
the same?
plus square root negative 12
So that's what you have, negative 8 plus square root of negative 12?
over
Okay.
40.
Okay. So first thing we'll do, just like before, is
So it would be 4 times 3, and then you would pull the 4 out and the 3 out.
Yep. Now don't forget the negative. Yep.
Right,
Because
which would
that
be
will
what,
give
negative 2, negative I or I.
yes.
And the I comes in when the number under the square root is negative, correct?
Yes. Uh-huh.
Okay.
Okay, so if it was a positive number, you wouldn't need the I, right?
It
Exactly.
would just be 2 square root 3, correct?
Okay,
Yes.
so the I is taking away the negative essentially.
Right. Right.
You
And
can't
so it's just
actually
the way you
square a
represent.
negative number. It's
Right.
imaginary.
So it's the way that it's
Right,
represented.
okay.
Yep. So now here,
40.
take that 40 into each
1/5 and 1/20.
Mhm. That's negative 1/5.
Don't you mean 20?
Yep. Really.
Hey, look at you
I
checking on the
just-
teacher right now.
I'm
I
trying to make sure that
saw-
my thought process is right, because
Hey, she's sandbagging, man. She ain't struggling.
Well,
this
I
is
feel-
okay.
I just
Believe it
saw
or
what my
not, this is
dumbass
my
did though.
3rd time taking this class. Once in high school, once I failed last semester, and this time.
Well,
I'm
we're
trying
gonna
not to be on that bus.
we're gonna knock it out this time. You'll be good. It's not gonna be a 4. Not gonna be a 4.
So I was like, okay, so I aced pre-calculus in high school, right? I was like, okay, so I can take it as an 8-week class. And then I got some like Asian math teacher. No, you never want an Asian math teacher. It's just not, it's not for me. They're too smart and it's just not okay. Can't do it.
I see what I did
It's-
wrong.
Okay.
After being out of high school for 8 years, no, we're not doing the Asian math teacher.
Viewing the example, I ended up switching. I don't know math terms, by the way, so I'm gonna just say the bottom number of the fraction.
Denominator. Yep, that's fine.
I switched that one for the one that was being shown in the example,
Oh,
and
okay.
that's why I got it wrong. My
Gotcha.
dumb
And
ass.
so the proper answer is going to be the -1/5 plus I square root of 3 over 20,
Yes.
correct?
Mhm.
Okay, so and you can type all that in, because I haven't got to that point in math lab yet, obviously, but you can type all that in with no problem.
Yes. Yep. Yep.
Yes.
All right.
Yeah, when you go to your answer box in math lab, there's like at the bottom, there's like
Yeah.
all these blue boxes that have
Mhm.
like a way for you to type all that stuff
Yeah,
in.
I've only had to do the fractions so far. I haven't seen the square roots of anything yet.
Mhm.
And I'm gonna watch that factoring video before I schedule some time with you, because I think
Okay.
that might help clean up a lot of things. But if it does not, then I definitely need to, because even just watching you work this problem,
Mhm.
like it makes more sense to watch you do this than to just sit here and write a ton of problems out and then just kind of listening to you. It's like,
Right.
where did that even come from?
Yeah. Yeah. And we're gonna have at least when we close out chapter 1, I'll have at least one day where I'm not gonna do anything and I'll just entertain questions. So I do that as well. So before we go on into chapter 2, there will be at least one review day wherein I'll just answer whatever questions.
Do you have any tips on, so my issue is I just can't, it's, if I see an example, I can do it
Mhm.
because I can follow along and I can make sense of it. But just slapping a problem in front of me,
Mhm.
I'm like, oh shit, what do I do?
Well, you might not like my answer.
Practice.
It's repetition. That's all it is repetition. And the more scenarios you see, the more, and it's really just like when you would do anything else. I mean, if you were a stunt driver, the reason why they're so great at what they do is because they do it so much and they've experienced so many situations where they know how to compensate, whether it be moving their body a certain way, you know what I mean? So it's really all about doing it so many times that you come across so many situations. And the way I explain it is it's like football. It's like you have to go into it that you've done it so many times that you're not trying to remember the playbook, but you're reacting because you ran through those plays so many times. It's not about the playbook. It's about now I'm just reacting. So we're actually reacting to the things that we see. Just like if this was just -8 square root of -12, you're going to react differently versus having a plus in there. You see what I mean? So you're reacting to the symbols that you see, but you don't know how to react unless you've actually been through those scenarios and those situations multiple times over. And you saw, oh, that didn't work, or I wasn't supposed to do that. Then you double back and do the right thing. So it's really all about practice. It's just that a lot of times people don't like math, so they don't want to put the practice in. I'm not saying that's you, but I'm just saying normally, because we want to do other stuff. You know what I mean?
It just seems like it's just no matter how much, but my brain works different. My brain's fucked up. So
I
I
would say
practice
that
at least 3 hours a day.
now it's
and
possible
it's
your
just don't
brain
make no
works
more sense.
different. I wouldn't say that it's effed up. I would say that it works different, and that's a possibility. And where it may take more time, you know what I mean? It's just everybody's different, so different concepts. And then we might go to further along in the class, and other things that just click. Wherein
Yeah,
in
wait till we
this
get to
something
graphing.
may not be that, that.
I mean, graphing is good. I like that, but this stuff.
Yeah, I
like
just need my
this.
reaction to not be a deer in the headlights look every time I
Yes.
see these problems. It's just like I feel like I'm staring down the barrel of a 20 gauge and just waiting for this hunter to shoot me. Like put me out of my misery, bro.
One of the things
Oh
that I
my
found really
goodness.
helpful is last semester, before we got to graphing, was in the book itself, not in the homework, but in the book. I don't know if Mr. Tucker, if you pull the example questions from the book, but the book kind of does the step-by-step thing that he was doing, where it walks you through step-by-step in an explanation next to the step of like how to work that problem. So it'll say, okay, here's the thought process behind what we're doing. And it's like, it's written out in words. So reading it and reading it out loud for me, because it goes through your brain 2 different ways when you read it on the paper and then when you read it out loud. So for me, that was helping when I got really, really stuck.
Do you guys notice that if like you go for like the video in math lab for a certain problem, that it's not really close to the actual problem that you're working on. They just do a generalization. So it's
Oh, no,
like
I've
if you're
noticed.
struggling
It's a
with one part of the
concept, yeah.
equation, you're missing the point. That video doesn't help you any. Am I the only one that feels that way?
I haven't watched the videos. I've only seen the written examples.
Oh, don't. If you haven't, don't. It's just gonna mess you up. Don't do it. Like, don't do it. Yeah.
Well,
And see, I was sitting here cursing this class. I'm like, when am I ever gonna use this? And then economics came up. And I'm like, ain't this about a bitch?
Wait till you get to physics.
Oh, yay.
Yeah.
Woo.
Well,
What's
with
your
that being
major?
said, you got
I'm doing business. I'm gonna do project management.
Business math is a bitch.
That's all right. My girlfriend's intelligent in that part, so I'm gonna use her for that. Just right now, none of us have used any of this in umpteen years.
Yeah, you gotta
So
get that
it's just
refresher
trying to
back.
get, I just
Yeah.
got to get it back. And once I get it back, like I know I'll be solid. But that's why I
Yeah.
think the factoring, I'm gonna bog that down before I bother you with a bunch of questions, because I think that'll
All right.
sew up some things for me.
Yeah, not a problem. Not
So
a problem.
do I need to send you an email? Because I think I've said like 10 times that I need it. But
I think somebody else has already sent that. So when that'll remind me to send it out to everybody.
All right, we're all gonna get it.
Yep.
All right, cool.
Or could you
All
just
right.
post it in the announcements tab so that anybody who needs it can just access it?
I do it. Yeah, when I send an email out, I put it there anyway.
Oh, okay, sweet.
I archive
Cool.
all my emails in the announcements. Yep. All right.
Well, y'all have a
You guys
good
have a
weekend.
one.
Thank
y'all
you.
too.
All right.
Appreciate it.
Take care.
See you
Bye.
later.
Bye.